We're going to take a look at another instance where the greedy algorithm is actually going to work to give you a pretty good solution. In fact, actually the best solution. And let's say we were running, I don't know, let's say a furniture company. So we own a furniture company. And we are obviously going to have customers who are going to bring us their jobs. And we are given, N amount of jobs to complete in a given day. And we want to complete them in overall the quickest amount of time that each person is going to be waiting for, right? That might seem a little bit crazy, but we want... So we're going to look at another instance where the greedy algorithm is actually going to give us the best solution. So let's say we own a furniture company and we have customers who are going to bring us their jobs for us to do, and we want to go ahead and do those jobs. Now let's go ahead and write a few ground rules before we actually get into how we are going to try to optimize whatever we are trying to optimize. We don't know what we want to do right now. So what we need to know is that we know a job, let's say job I, so a job from customer I, will take us TI time. So sometime TI will be the amount of time that it's going to take. We can only do one job at a time. We don't have much machinery. Each customer, and this is the part where we're going to want to try to optimize it. Each customer wants their job done as early as possible. Now that might seem like it's not going to matter, right? Because if we have, a bunch of customers, we can only do them one at a time. How are we really going to optimize it, right? Because somebody is always going to have to wait the longest. But that's not actually going to be the case, right? Even though you will have somebody always waiting to be the longest, that doesn't mean that there aren't ways that you can order this so that overall, if you sum up all the time that people are waiting, you can actually make people save time. And if you visualize this, you might be able to figure it out, but I will be showing you guys how to do it in a moment. So essentially, let's say we have jobs from customer. We have customer 1, then we have customer 2, and we have customer 3. Well, customer 1's waiting time, so his waiting time is going to be just T1. Customer 2's waiting time is going to be T1, so the first waiting time plus T2, because you can only do them one at a time. And then customer 3, his waiting time will be T1 plus T2 plus T3. Now, if you order these in a particular way, you will actually be able to save the overall time, because we want to minimize, and this is where the greedy algorithm will come in, the sum of N, I1, WI. That's simple. We want to minimize these amounts of time. So this is waiting time for number 1, waiting time number 2, and waiting time number 3. So think of it like this, right? If you were to have the longest job first, because all the jobs are not going to take the same amount of time. If you had the longest job first, well, that means all the other customers after that are going to have to wait more time than if you were to have put that longer job at the end, right? So that's essentially what we are going to do right now. We are going to, it's a more simple solution that we are going to want to schedule the shortest jobs first. And that's essentially what this is going to be about. That's essentially the goal of the greedy algorithm. There's no other ways we're going to look at this. Schedule the shortest jobs first. Schedule the shortest jobs first. So to do this, let's get a new color, because I've used the same one the entire time. So we are going to make sure that we want to sort the jobs. We sort the jobs by their length. All right, so sort them by their time, and obviously we're going to want to make sure that T1 is going to be less than or equal to T2, which is going to be less than or equal to T3, which is going to be less than or equal to ... all the way to Tn, right? Because that's going to make sure that they are in order, and that means that we are going to get the best possible solution, right? So if there exists a job where an earlier time TI is going to be greater than TJ, you'll need to switch those jobs. And if you keep, switching those instances, you're going to arrive at a time where, go ahead and try to draw this out here. You'll arrive at the best solution by doing those switches. So let's go ahead and write this out. So assume these are going to be your times, right? So this is where you're starting the jobs, and this is the end of your jobs. You want to put them in order here. So say you have a job over here. Actually, let's make them small because we want the smallest one first. We have a job over here. Then we have a little bit bigger, a little bit bigger, a little bit bigger, and then we have this big job right over here. And then, this is not going to give you the best solution, right? Because T1 is smaller than T2, which is smaller than T3, which is smaller than T4, except we have this one over here. We can call this, I don't know, I'll call it TJ or whatever. And then we have TI over here. These will clearly need to be switched if you want to get to that best solution, right? I know it's pretty simplistic, but in this case, the laziest possible solution will give you the best possible answer. So it's pretty much simple as that. That's what we are going with this algorithm. So we want them sorted by their times, and we want to put them in order based on how long they are. And then the shortest ones at the front will give you the most amount of time. If you're still having trouble visualizing why this is the case, we'll see all these times over here. So this is T1, T2, T3, and T4. These are going to stay the same. And then when we compare the two possible outcomes with this, we can have this one, which is going to be TJ, and we have this one, which is going to be TI in this first case. And if we were to switch these around, where I'll go ahead and now we'll say that theoretically this is going to be TI, and then this over here, this whole thing would be TJ. Now if we wrote out those times, and you'll see how it's going to be shorter. I go ahead and write one like that, and I go ahead and write this one that's going to go all the way to the end. Well, we clearly see over here that this is all time that is coming out of, there's no need to have this time here. If you'd make that 1, this can be removed. So can be resolved. Just by using the greedy algorithm, that time that we have there would be cut out of the picture. So anyways, that is all I have for this algorithm. I don't think I will make anything more about it. I could give you a bit more information on some sums and permutations, but I think I'll just pass and leave it like this. So thanks for watching. Leave questions below. See you in the next video.